Today we are going to do section 2.2, where the second part, where we consider all the lines. All right. Now to start with, we are going to consider something called the slope. The slope in general means how steep a hill is. Okay. For example, if you walk along a level hill, that has called zero slope. It's not going up at all. A little bit steep is called a small slope. Okay, as you go up, there's more and more slope until you go completely vertical. It's called infinite slope. Now, in general, the slope is calculated by something called rise over run. Now, we will demonstrate exactly what that means. A rise is how much you go up divided by how far you're going across. So the bigger the rise, the steeper your slope is, okay? Or the smaller the run is, okay? You're going up a little bit, but going across even smaller bit, then your rise is still very much. Now let's see an example. I picked two random points. Let's pick 1, 1, which is right about here, right? And then 3, 4. So we'll go over 1, 2, 3 this way, and 4 up. So we'll go up 1, 2, 3, 4. Okay, so that's 1, 1, and this over here, about here, that will be our 3, 4. All right, so we'll connect this with a line that is our hill. As you can see, that's pretty steep, right? But how would you calculate the slope? The slope is calculated by the distance here. That is, what is distance here? This goes from 1, this is to 3. Okay, this is 1, 1, and 3, 4. So this distance goes from 1 to 3, so it is the distance of 2, right? 3 minus 1. And then this going up, we're going from 1 to 4. So the whole distance is 4 minus 1, which is 3. And therefore, the slope for this case will be equal to, what is our slope? Okay, slope will be equal to 3 over 2, which is a pretty steep slope. 3 over 2. All right. As you can imagine, you can have a much gentle, smaller slope, such as 1 over 2 or 1 over 100. Let's say if you have to go across 100 feet before you rise 1 feet, that is a very small rise. You barely can tell, right? And then if you say, what if I have a slope that's 100 over, say, 3? Now that is a pretty steep slope, because then the slope is going way out. But either way, no matter how the slope is, that is how you calculate the slope. The going up is called the rise, R-I-S-E, and the rise in this case is 3. Okay, the going across is called the run. You're running across, I guess that's why they call it. And so that's why the slope is defined as the rise. Start with R. The slope is defined as the rise over the run. Rise, I-S-E, over run. All right. Now the slope in math is often called m. We use the letter m to represent slope. Slope is m. And you might wonder why. I don't know. That's just what everybody calls it. Okay, so when you see the letter m, which doesn't help you remember at all, you need to remember the m is talking about the slope, which is the rise over the run. Now, in algebra, we can represent these things with letters. For example, 1, 1 will represent it as x1, y1. And then 3, 4 will call it x2, y2. And what's with all the y2s and y1s? Don't let it confuse you, because x1 just means the first x, and x2 just means the second x. That is, x1 together is one symbol, and it represents the number 1 here, and x2 represents 3, and similarly y1 represents 1, and y2 represents 4. And there's no particular reason why we use these. I mean, for example, we can use x2 to represent 1, 1 instead. Doesn't make any difference. It's just we just want to talk about them. Okay, the first guy, okay, we'll refer to that, and this is the second guy, okay, which refer to that point. And the slope formula, therefore, is given like this. Being that it's rise over run, we write it as the rise is the difference. That is, for example, in this case, it's 4 minus 1, that equals to 3. So the right is also called y, we normally call it y2 of minus y1 divided by x2 minus x1. And that is how the official formula of calculating slope. But what that means is you figure out what x2 is. Figure out what y2 is. In our case, y2 is 4, okay? And then y1 is 1, and do the subtraction. And then x, you do the x the same way. But that is the reason for this. And this is a very important formula. I would like you to memorize it. Okay, the slope, that is the formula of the slope, which I also wrote down here, is equal to y2 minus y1 over x2 minus x1. Whereas the y's are the ones in the y coordinate of your point, and the x's are the ones in the x coordinate of your point. So that is how it is done. As you can see, if you reverse the names of these 2 points, the slope doesn't change because you are doing division. When you divide, then when you reverse it, then then things just become negative and it cancels out. So in other words, it doesn't matter which point you're calling x2, y2, okay, or which point you're calling x1, y1, as long as you're consistent. That is, if this guy's y2, then that guy better be x2, okay, and if this guy is y1, that guy had better be x1 because they are a pair, right? So that's how we do the slopes. Now, once we understand how the slopes is done, the next step we're going to do is just blindly follow the formula, okay? Because we understood it, and now we're not going to, now we will stick with the formula and do what it says. So let's go to the next page. I'm on page 105, where we have example 8. And you are supposed to find the slope of this thing. As you can see, slope is represented by m, and for no reason at all. And so let's look at this problem. We have 2 points, and 2 minus 1, and 5, negative 5, and 3. Therefore, the only thing we care about is identifying what is y2 minus y1. Now for example 8, let's see. So right now we are in page, I'll stand on this side, page 105. Okay, so I'll write it here. Page 105, example 8, where we have 2 points. We have, and we need to identify which is x2 and which is x1, and it doesn't matter which one you call it. It's like calling one kid Susie and the other kid Steve. Doesn't matter which one, as long as you're consistent. Don't call the kids Susie one time and Steve a different time. So right now we'll just call this. Okay, we have 2 points. So this will be we'll call this guy x1, y1. Yeah. And then the second guy is minus 5. Second point is minus 5 and 3. We'll call this one x2, y2. And then we are going to do the subtraction and by identifying each one. So the formula goes like this. So the slope then, which is m, equals to y2. See, y2 is 3, okay? And minus y1. y1 is minus 1. And that's fine. We will subtract it like it is. We'll just plug it in and subtract it. Doesn't matter if it's negative or positive, okay? And then similarly, x2 is negative 5, and then minus x1 is 2. So the only hard part about this is don't get confused and add the wrong thing. That's it. Make sure you remember which is what. Once you do that, then everything comes out. So this 2 negative becomes a plus. So this becomes 3 plus 4. 3 plus 1, which equals to 4, and then this becomes minus 7. You have minus 5 and minus 2 again, and that is negative 7. Because all the negative stuff add together, and that is correct. Okay, and so please do example 8. Okay, redo example 8 as part of your homework. Next, let's go to page 106. we're skipping over example 9 for now. We'll do that in a few moments. So, but I want to go to page 106 so that we can describe the point slope formula. Now, the point slope formula comes from this equation. Now, this is the slope of 2 points, okay? There's x1, y1, and x2, y2 in here. Now, what if we just describe it as any old point? Now, any old point, x and y, doesn't matter what point it is, can be written like this. So we have m, okay, the same m. Following this formula, we have y minus y1 equals divided by x minus x1. Now, in this equation, this is the equation of a line that has the slope of m. The variables here, now remember, these are the numbers, okay, like that would be a sample. Whereas these are the variables that for your equation. As an example of that, well, we'll look at the example of that in a second. So this is called the point slope formula, which does come in very handy, and that's how you find out the equation of some line, okay, and which we'll do that. But for now, this is how we come up with this point slope formula, is by substituting y in the position of y2 and x in the position of x1. And as you can see, that gives you this, the slope of a line is constant and is called m. So let me clean off the board. Oh, but before I clean off, I should mention that therefore, because of this, then here's this equation, where another way of saying this is y minus y1 equals to m times x minus x1. Then, and we came up with this, that's a 1 there. Yeah, x1. Okay, so I have an m there, so this is the equation on page 106, and that's where it comes from. And also, anytime you see an equation that looks like y equals to m times x plus some number back here, okay, then m is automatically the slope, but that's only if y has nothing in front, just 1, okay. Then m, and if your equation cleans out this way, then m is always the slope. So next, let's go to example 9 on page 105, where we have this equation of a line. Y is negative 3/4 x minus 4. Our job here is first we need to identify the slope. Now, any equation that looks like this, the slope is automatically the number in front of x. Okay, if y, the number in front of y is 1 and x is on the other side of the equation, then the slope is the number in front of x. So therefore, we can immediately say that the slope of this thing is the slope equals to negative 3/4. That's it. And the second question we are to ask is, what is the y-intercept? That is, y-intercept means if x is 0, okay, what is the value of y? 0, what's y? Because what happens is that means on the graph, okay, this thing when x is 0, so x is over here, x, y. When x is 0, y is whatever value that is. Now, if x is 0, let's pretend x is 0, that kills this whole chunk. So we only have negative 4 left. So the y-intercept is minus 4, which means that we'll go down to minus 4 here. Okay, let's say that's minus 4. And this is the y-intercept. What that means is when x is 0, you can't go out this way, so you can only go down negative 4, which means the line is going to cut the cross the y-axis at negative 4. That's why it's called y-intercept, is where the line intercepts the y-axis. Okay, so the y-intercept for this problem is at 0, minus 4. In general, y-intercept is always at 0. Okay, because it's is on the y-axis, and everything on the y-axis has 0 for x coordinate because it's not allowed to get out. Okay, it has to stay here. So that's example 9, and please do example 9 yourself as part of your homework. And so let's go to the next page, page 106, and look at example 10. So next, let's look at example 10 on what page is that? 106. Okay, on the following page, and then we have the situation where given the slope is -3, and then the point. We have a point that's 4 and 8, and we're supposed to calculate figure out the equation of the line that has the -3 slope and then goes through some point called 4, 8. Now -3 slope, any slope that's minus means it goes down basically. Okay, and that's the positive and minus. Just positive slope means go up from the x-axis, and from your direction, yeah. Anyway, positive slope goes up, negative slope goes down. Anyway, it's just a left and right situation. But anyway, so how are we going to do that? Well, we are going to use this equation right here. Okay, we remember y1 and x1 are numbers, whereas y and x are variables, and m is the slope. So we're going to plug everything in as is. Therefore, that is, we'll set 4 and 8 to be x1, y1. x1, okay, y1. Now, if that is the case, then we'll put everything in this equation right here. So we have, then we have y minus, the equation stands as y minus y1, which is 8, equals to m times x minus x1. X is the variable, minus x1 in our case is 4. And that is our equation. Okay, oh, sorry, I forgot to write down m. What's m? M is -3. As given. In our case, m is -3, right here. So this is our equation. Now, having written that equation, now we will clean it up a little bit because so that it looks more like the answer in the book. Okay. So then we will do a bit of a cleaning. We'll keep y on one side, and then so we have -3x. Okay. Multiply this stuff out. -3 times -4 is positive 12, and the -8 moved to the other side, change sign, becomes +8. So then the final answer is y equals -3x plus 20, if I'm not mistaken. Is that right? Yep, it is. Okay, so please do example 10 as part of your homework. Now, in example 10, we were given the slope and then 1 point. Now let's look at example 11. We're no longer given the slope, but we are given 2 points. So we are again supposed to write down the equation of the line. So how are we going to do that? What we're going to do is, being that we do have 2 points, we're going to calculate the slope based on this formula. Okay, and once we have the slope, then we will have a slope and at least 1 point, and we'll use the same trick here in example 10 to calculate the equation of the line. So first thing first, let's calculate the slope. The m equals to, we'll call this x, which one's x2, which one's x1? We will just, we'll call this x1, y1, okay? And then x2, y2. Doesn't matter which one you call it, is the same thing. But anyway, and then we'll subtract following this formula exactly. So we have y2, which is -3, okay, -3, subtracted by y1 is 4, divided by x2, which is 0, minus x1 is 3. So that equals to -7, okay, divided by -3, which is 7/3, and that is the slope. So we have calculated the slope that was given to us earlier in the previous case. So now we have the slope and a point, and which actually we have slope and 2 points. So we'll pick any point, okay, to do this. We will pick the one that has 0 because 0 probably make things easier. So now we have the slope, okay, right here. We have the slope, and then 1 point, 0 minus 3. All right, so then now we're going to apply this formula right here. That's called the point slope formula, okay? Point slope. And that will give you the line of the equation. So we have y minus, we'll call this thing, in this case, to follow this formula, this will be x1, okay, y1. I know that previously we call it x2, But that's just to calculate the slope. Now to follow this formula, we'll change its name to x1 y1 to fit into this formula. So from this point on, this will be x1 y1. And then in order to follow this formula, we'll have y minus y1. In this case, is -3. Do not forget the negative sign, okay? The -3 is all y1, and equals to the slope, which we calculated to be 7/3. And then times x is the variable, and then x1 is 0. So that is our equation. But chances are let's see, what problem are we talking about? 11. Okay, and then we'll see the rest of it. The way we are going to do this then is this is pretty much done, but normally we want things to look kind of like that. So we'll move the -3 to the other side, okay? So then if you move it to the other side, it becomes, so this is just 7/3x. And then the -3, being that it's a minus kicked to the other side, it will become a plus -3, which is still -3. And that is our answer. Okay, so please do example 11 as part of your homework. Next, let's do example 12 on page 107. Now this time we are given the slope, right? And then also a point. So we are going to apply the point slope formula. Let's write that down. But before I say that, I should mention that your book wants to talk about something called the standard form of a line. Let's look at it on the same page, in the middle. The standard form of a line just means that you want to put x and y on one side and the numbers on the other side, the constants. And so that you just rearrange it, and that's called the standard form. So we'll do that. But first, let's come up with the equation. What is the equation? We have, we'll apply this formula, the point slope formula, being that we have a slope and a point. So we have applied this formula. We have y, that's the minus, okay, figure out which one is it. This is x1, okay, and that's y1 for this formula. So we have y minus y1, which is -2. Don't forget the minus, okay? Just because you have a minus sign here doesn't mean that you can get rid of that one. Y minus -2, that's y1, equals to, following the formula right here, slope, -6. And then x, write down x minus x1. x1 in this case is 1/4, so let's write that down, 1/4. And that is the equation of our line. However, remember the book wants you to put all the x's and y's on one side and all the numbers on the other side. So we will do that. So we have y here, okay? And then this is -6x. We will kick it over here on this side. The negative becomes a plus when you move things across the equation line. The equal sign, I mean, so that becomes plus 6x. And on the other side, we have -6 times -1/4. That is, that will be equal to, we'll just write down 6/4. Okay, positive 6/4. And then this thing, push this number to the other side, is a minus -2. Push it to the other side, becomes a plus -2. In other words, just -2. And that equals to whatever that equals to. Okay, let's do fractions here. How will we do the fraction? That would be, the 2 is 4/2, so 6 minus 4, and that would be 2, right? And then the denominator is still 4. And then we have, this should be equal to 1/2. And that is your equation, is y plus 6x equals to 1/2. Now let's check to see if I got my math right. Okay, now did I get the sign right? And let me see, because your book has the sign on the other side as a negative. Yeah, 6 plus this. Now let me check. Oh no, I did the fraction wrong. Can you believe that? Now we have, so let's get rid of that. This part is wrong. And then try again, okay? Now 6/4 subtracted by 2, what is 2? 2 is 8/4, right? I mean, what was I thinking? So this equal to, being that 2 is 8/4, then 6 minus 8, that should be minus 2 over 2, and which is -1, which is what your book says, okay? That's still not quite right though. Let me check again. Yeah, I mean 2 over 4. Where did I get 2 over 2? So 2 over 4, all right, this is equal to -1/2. Okay, so finally we have got to this, but there's a fraction here, and your book doesn't like fractions. Well, nobody does. Therefore, we will change it to, we'll multiply the whole thing by 2 and to get the same answer. So multiplying y by 2, we have 2y plus 12x. Okay, multiplying everything by 2, and the other side is 1/2. Multiplying by 2, that gives us -1. So that is that's how this problem is done. So please do example 12 as part of your homework. Just don't make the mistake I made, okay? Now next, let's look at page 107, where we consider vertical and horizontal lines. Now what that means is, what happens if a line is completely horizontal or completely vertical? How will we represent it? The horizontal lines are represented as y equals to a number. Let's, for example, consider y equals to 5. Okay, I'm just making this up. Let's consider the line y equals to 5. That means no matter what x is, y is 5. If x is 0, y is 5. Okay, when x is 1, y is 5. When x is -1, y is still 5. Doesn't matter what x is, y is always 5. And therefore, you draw a line, so then y equals to some number is always is the horizontal line. And for any horizontal line, the slope is 0. Okay, that is because there's no rise. Okay, so the rise is 0 no matter what the run is. So therefore, that is called so y equal any number. Okay, let's make up another one. Y equals to -1. Then that's the line down here. Here's y equal to -1. This is y equal to 5. And here we have y equal to -1. So any horizontal line, just all you say is what the y value is, because x is whatever it is, y is still 5, or y is still -1. Now, on the other hand, vertical lines, okay, perfectly vertical lines, described as, say, x equal to 3. Why? Because it doesn't matter what y value is, x is 3. For example, when y is 0, when x is 3, y can be 0, okay, which is right here. Y might be 1, might be here. Y might be -5 here. Well, whatever y is, x is always 3. And this is a line, and this is a line too, okay? Even though it just says x equal to something, this is actually to describe a line that says x is 3 no matter what y is, all right? So when you draw the line, then you get it going up and down like this, and this line is described as x equal to 3. And we can draw another one. How about x equal to I don't know, 6, maybe? So you go, here's 0. We go this way in x direction, 6 units, okay? -6, right? And then, well, whatever y is, x is always -6. When y is 0, x is -6. When y is 1, x is still -6. Okay, no matter what y is, x is always -6. So when you draw a line, then you realize this is a vertical line, and we'll call it x equal to -6. In general, anytime your equation is x equal to something, it's always a vertical line. See, and where x is always -6. Now the slope of the vertical line is called infinite. That's because and there's not a number big enough to describe its slope. Its slope is is infinite. Okay, and and so as a result, that's because it rises so much, and there is no run at all. It just went straight, straight up. Well, and so the slope is called infinite for the vertical lines, and it's called 0 for the horizontal lines. So basically, a slope goes from 0, okay, when it's level, and then go up and until it goes infinite. Or if it goes down the same way, okay, it becomes negative until the slope is infinite again. So in any case, the slope for vertical lines are infinite, and for horizontal lines, it is 0. And these are the equations for horizontal or vertical lines. Now, so that is good. So let's look at an example. Example 13. Okay, we're finding the equation passing through the points 1, -3, and 1, 4. Now you notice that the line goes through 1 both times. X-axis is 1. That means x is always 1. Okay, and as a result, you won't be able to pull any of these tricks because there's something that x is always 1, then this is not going to work. Because you have to, because your slope is 0, then m is going to be 0, and well, actually, I think for the 0 slope, it might work, but either way, why bother? Okay, just remember that when the x-axis is the same for 2 points, your equation is x equal to whatever it is the same. In this case, it is 1. Okay, and then similarly, if you have a problem where the y value is the same, like say, let's make that up right now. Let's say you have to draw a line through some points, I don't know, 0, -1, and then another point that has the same y value, okay, maybe 5, maybe. And in that case, the equation is automatically y equals to -1, because y is -1 in both cases. Then y is always -1, which means it's a horizontal line where y is always -1. So that's how you do this type of problem. So please do example 13 as part of your homework. Now next, let's look at page 109, where we consider parallel and perpendicular lines. Now parallel lines are lines with the same slope. That is, m is the same value. Everything else can be different, but m is the same value, so that they all go the same direction, which means they're never going to intersect. Okay, they're going exactly the same way. Let's look at the graph on page 109. See, we have 3 lines here. They all have the same slope. And as you can see, they're all parallel. Now, there is a way to prove that too. And I will do the proof later in this course. Right now, we're just going to do the introductory concepts of all the lines. So we're not going to let ourselves bogged down by the proofs yet. And well, one reason your book isn't going to bother. Okay, so I'm not going to do that right now, but I will do it before the end of this course so that you know exactly how the proof happens. Now the next concept is the perpendicular line. Now the perpendicular lines has a specific quality. That is, if you have 2 lines that are perpendicular, that's only possible if it is true that the line 1 the slope of the first line, we'll call it m1, okay, and times the slope of m2, the other line, slope of the other line, happens to be -1. And in other words, there is a way to say this, which is that 2 perpendicular lines have negative reciprocal slopes. Okay, in other words, m1 times m2 of the slopes equals to -1. And that is a formula that I ask you to memorize right now, and then that you will be using it to calculate slopes that are perpendicular. That is, if you're giving a certain line, then they ask you, what is the perpendicular line to that? Then you just take the slope and make it the negative reciprocal of the other slope. And we will see how that is done in a second. Well, or put it this way, if you have m1 times m2, the book didn't say that exactly. Fine. So if you have m1, m2, 2 slopes, okay, it equals to -1. That just means that the one slope, m1, will be equal to -1 divided by m2. When you push this thing across the equal sign down to the bottom of the division line, because they're being multiplied together. So if m1, that is the equation that you're going to use to find, say if you're given m2, okay, you know what m2 is, and you're supposed to calculate m1, then you just take -1, divide by it. So when you're given a slope, say a slope of some line is 5, and then you need to calculate the slope of something that is perpendicular to it, then that slope will be -1/5. Yeah, just as an example. Now, as a better example, let's look at, what are we doing here? Okay, let's look at example 14. All right, so now let's look at example 14 on page 109, I believe. Yep, and then let's see, what are we trying to figure out here? We are given 2 lines, and we're trying to decide, are they perpendicular, parallel, anything, right? So to do that, we will figure out what the slopes are. We'll call this line slope m1, okay, and this one will be called m2. Now, to calculate m1, what is the slope m? M is the number that's in front of x if y value is 1. I mean, the coefficient in front of y is 1. So to make it look that way, we'll rewrite the equation 1. Okay, I'll call this equation 1, and this is equation 2. We will rewrite equation 1 like this. Make this thing into make the 3 into a 1, and we'll do it by division. So dividing by 3 across the board, we have y, okay, because the 3 got divided out, equals to minus 4/3 x plus 3 over 3, which is 1. And then, so the m1 then equals to this number right there, being the m is the number in front. So m1 equals to minus 4/3. And similarly, we'll calculate m2 like this. We'll isolate the y in front of it by dividing, well, first let's rewrite this thing, okay? So we'll rewrite it so it's clearer and less likely to make a mistake. So we'll rewrite this thing. So minus 4y, push the x to the other side, it becomes negative. 3 plus 8, right? Plus 8, that's an x there. All right. And then y then equal to, now we're going to divide everything by the number in front of y. In this case, is a negative 4. And so that would be minus 3x divided by minus 4, which becomes positive, right? And then of course, the 8 also divided by minus 4. Therefore, the m2, the slope of this thing, which is the number in front of x, okay, from this equation, or this one, either way, and the slope is the number in front of x if y has the coefficient of 1. So what is the slope? The slope will be equal to positive 3/4, 3 over 4. So that is our slope. So that's m2. Now that we have m1 and m2, then let's look at it. Are they the same? The answer is no, okay? Because if they're the same, then the lines are parallel. Now the second question, do they multiply to be negative 1? So let's check. So m1 times m2 equals to minus 4/3 times 3/4, and that is indeed negative 1, and therefore the two lines are perpendicular. Now the lines can either be parallel, perpendicular, or neither. Okay, there is not another a fourth option. So our conclusion is that these two lines are perpendicular. So please do, this is example 14. Please do example 14 as part of your homework. So next, let's do example 15, where we have we need to come up with the equation of a line that is parallel to this particular line, and then it has to go through some point. So the first, what we're going to do is first we need to figure out what the slope is. Once we have the slope, we'll be able to use this formula over there. Okay, so what is the slope of this thing? We will follow the rule here. Okay, we need to write things like this and to be able to hunt down the slope. So let's write this equation in that form. We have, we'll rewrite this thing. We have, so we have 3y, right? I'll write down 3y equals, we'll push the 5x to the other side of the equation, becomes negative. Anything that's pushed across the equation sign, it'll become negative. And then the 1 is still on this side, on the right side, so we'll keep it that way. And then secondly, we need the y to be by itself with just 1 in front. Okay, so we'll do that by division. So then y equals to, divide this thing, minus 5 over 3x. Okay, push the 3 down across the equal sign to be under the division line of each item. So that is 1 over 3, right? You just push it clear down. So now it's over here. And it has to be under everything, okay, if there's a plus sign, that is. Because each thing in addition is a thing by itself. So that's how you solve any equation. Okay, push it down across to the bottom of each item. And now that we've done that, so then the m is equal to minus 5 over 3. And what are we doing? Oh yeah, parallel. Okay, so then we are going to, parallel means the same slope. So knowing that, we're going to follow this equation right here, okay? Where is y minus y1 equal to the slope x minus x1. And in this case, we will have x1 as 3, okay? And then y1 as 5. And then we'll follow this formula exactly. So the formula of our new line stands as y minus y1, which is 5, equals to the slope, same slope, so it's minus 5 over 3, the slope times x, plus, parentheses, forgot the parentheses. I'm following this formula right here. Okay, slope times x minus x1. X minus x1 is 3. So the tricky part is just to keep track of what you're doing, okay? Which is x1, which is y1, don't mix it up. And then you get the right answer. So this is the answer. However, our book probably wants us to get rid of the fraction and add up some numbers and stuff like that. So let's see what we are looking for. So eventually we want, we don't care about the fractions, just fix the numbers. Okay, so then we'll push this minus 5 to the other side, okay, becomes a plus. So that our final answer is y equals to, we'll push the plus 5 to this side, and then fix this stuff up. So multiply this out, so this fraction multiplied by x, the first one minus 5 over 3 times x, and the second one, this is minus 5 over 3 times the negative 3, that becomes positive. See, negative, negative becomes positive. Keep very careful track of that sort of thing. And then the 3 cancels out with this 3 on the bottom, because this 3 is the same as 3 over 1. Any number is the same as the number over 1. So when you so this can cancel out in multiplication, and we have just 5 left, okay, a positive 5, right? And then, so then the entire answer, this will be the answer, except that we're doing plus 10. Is that what it says? Yep, that is correct. So that's how you should write it out. But I will stop now because I'm out of space, and plus I'm lazy. So anyway, so that will be the answer, as you can see in your book as well. So finally, so this is example 15. Please do example 15 as part of your homework. So next, let's look at example 16 on page 110, same page. We have, now we need a line that's perpendicular to this equation, but it also goes through the point, some specified point. And to calculate that, then we remember what we just learned a moment ago, which is perpendicular means the slopes of the two lines and has to multiply to be equal to -1. That is, they're called the negative reciprocal slope of each other, or something like that. But all you have to memorize is m1 times m2 had better be -1. Okay, so to do that, first we figure out what m1 is. We'll call this the slope of this thing m1, okay, and then calculate and then decipher what it is based on this equation by isolating y. And to do that, we have we'll put y on one, keep y on one side, so that's -3y. Okay, and then push everything else to the other side of the equal sign. So 5x pushed to the other side becomes -5x. Everything changed signs. And then positive 4 changes into -4. And that's first step. Second step, we divide everything by -3 by pushing it down across the equal sign down to the bottom of the division line. That is, this becomes -5 minus 3x. Okay, don't forget the negative sign, okay? That comes right along with it. And then -4 divided by -3. All right, so then the slope, then m, is equal to this 5 over 3 because the negative signs cancel out. Therefore, m1 is equal to positive 5/3. Okay, so then the next step we have is figure out what m2 is, because m1 times m2 has to be equal to -1. So then m2, let's do the math here. Okay, m1 is 5/3, right, times m2. The slope of the equation we're looking for has to equal to -1. So to do that, so to solve this, we are going m2 then equal to push the 5 down, okay, -1. This is this, and then lift the 3 up, So 3 goes up and 5 goes down. This is also called cross multiplying. It doesn't matter what it's called. You push anything, any number, you push it down. But if the number is on the bottom already, you raise it up. Do the opposite, okay? Across the equal sign. So that is how you solve for M2, and that is, therefore M2 is negative 3/5. And you can quickly check the M2 times the M1 there. It will definitely become -1 because everything cancels out, right? 3 cancels out 3, 5 cancels out 5, and you got the negative sign left, which means -1. So that's good. And so now we have M2, and then we have a point. So we have a slope and a point. Therefore, we're going to use the point-slope formula, the one on top. So what is, to use the point-slope formula, we better figure out this is x1, this is y1, okay? And then following the point-slope formula, we have y minus, maybe I should write it on the bottom to not be confusing. Okay, let's see. So we'll write it, yeah, maybe here. So y minus y1, which is 1, okay, equals to m, this thing, minus 3/5 times x minus x1. x1 is right here, minus -4. Okay, don't forget the negative sign. Just because it's negative doesn't mean you can forget the negative sign. It has this, it comes right along with it. Now, once we have done this, then I think we're doing pretty good. Let's see what the book wants as an answer. This is, okay, the book just wants us to multiply this out a little bit, which is fine. And then we have then, finally, I'm kind of out of space, so I'll write the final answer over here. Okay, so we have y equals to minus 3/5 x. I'm going to, let's push the -1 to the other side, becomes a +1. Okay, and then this times, that's positive, so it becomes negative, okay? So in other words, you have 3 negative signs together, it become negative again. Keep very careful track of the signs. So then, and then to multiply a fraction by a number, you multiply 3 times 4, which is 12, divided by 5. All right, then +1, so that would be equal to whatever it is. That would be -7. So this part will become -7/5, I believe. And then that will be the answer. Now let me check to see if I messed up or anything. That looks, yep, that is correct. That is what the book says. So it must be right, okay? And so that's example 16. Please do that as part of your homework. Now first, I noticed that I wrote this part wrong. This is not part B, this is part 2 of this section, okay? So please, sorry about that. That is should be part 2 because we already did part 1, which was divided into part A and B, and that's why I was confused. Now for homework of this section, please do on page 112 problems 23, 25, 27, 29, 33, 45, 53, and 55. Now I won't be going over the homework because the homework is identical to all the examples that I've already presented. So if you work through the examples carefully again by yourself, you shouldn't have any trouble with the homework. So that marks the end of this section.